สวัสดีค่ะ Hello. We would like to introduce you to our project ABOHISE-L5, which stands for Asteroid Belt Object Hyperspectral Imaging Survey Explorer on Mars-like orbit Lagrange point 5 by team KALAM PLI PHAT NAMPLA by STAR. The asteroid belt is a vast region in our solar system situated between Mars and Jupiter. Primarily composes of rock and metal categorized as S, C, and M types. Exploring and mining these asteroids would provide access to valuable minerals, offering opportunities to advance technology, manufacturing, and utilize resources in innovative ways. It goes beyond space exploration. It has the potential to drive significant advancements in various fields. Over the past several decades, there has been significant development in studying extraterrestrial entities, both through observation on Earth's surface and the deployment of spacecraft for exploration and sample collection. And the mission of particular interest in the one set out of study near-Earth objects or NEO, such as the NEOWISE and NEO-Surveyor projects, which hunt for asteroids and comets in the Venus-like orbit region. This led us to ponder why not create a spacecraft to orbit in a Mars-like trajectory to explore asteroids within the asteroid belt.
Our main objective is to gather precious information and categorize the asteroid belt, shape it into a treasure trove of big data for any exciting further projects. So we proudly present our spacecraft observatory designed for collecting big data from the asteroid belt, ABOHISE-L5, which stands for Asteroid Belt Object Hyperspectral Imaging Survey Explorer on Mars-like orbit. ABOHISE-L5 is an 8-year mission to explore the asteroid belt, featuring a standout 6-meter hyperspectral imaging telescope, allowing us to accurately categorize types of asteroids. The mission will orbit the Martian Lagrange point 5. This position is close enough for precise data collection, and the mass will not exceed 1,300 kilograms. Let's focus on going to Mars-like orbit, especially at L5. L4 and 5 are the most stable points among the Lagrange point, where a spacecraft can orbit the Sun by itself without using any propulsion system, benefiting from three-body force. L4 is positioned in front of Mars, whereas L5 is situated behind it. We choose L5 because Mars can act as a space shield, providing protection for ABOHISE-L5. Nothing is likely to collide with it before Mars does. Additionally, there is no risk of communication loss between Earth and L5 point. The question is, when is the perfect timing for reaching our destination? I have already done some calculations for you. The shortest transfer orbit has a semi-major acid of 1.262 AU, aligned with Kepler's law, allowing us to reach this orbit within 261 days. Considering the requirements for L5 is to be positioned at a 60-degree angle with Mars. The optimal launch time is when Mars and Earth are at a 75.64-degree alignment. To execute this mission, we have selected the Falcon 9 rocket from SpaceX, scheduled for launch at a Cape Canaveral to propel our ABOHISE-L5 into the cosmos.
Now I would like to talk about spacecraft. We select hyperspectral imaging to be a payload. The reason behind this selection is wider wavelength for cover all minerals on asteroid belts, including rare earth elements. Hyperspectral imaging uses the concept of capture light reflect from asteroid, separate into its individual wavelength or spectral band. So we design hyperspectral imaging wavelength ranging from 250 to 5000 nanometers and other parameters as shown in slide. We also use CMOS image sensor for this mission. After hyperspectral imaging receive spectrum, then use AI to identify the prospective wavelength mix of the spectrum in 1 pixel. Next is about platform of spacecraft. The spacecraft platform consists of 6 subsystems. ABOHISE-L5 uses photovoltaic-type solar system together with lithium-sulfur battery. The maximum depth of discharge of the battery is about 20% for long lifetime battery. Second is radio frequency subsystem. as combination between ground and satellite. ABOHISE-L5 use S-band frequency at 2048 kilobit per second for controlling and gathering the measurement data, and X-band frequency at 400 megabit per sec for data downlink from spacecraft to ground station. Third, the altitude and orbit control system. Subsystem is responsible for measuring the location of spacecraft, planning the motion of spacecraft, and controlling the spacecraft in the correct direction by using sensors and actuators. Fourth, onboard data handling subsystem is responsible for controlling and monitoring the operation of spacecraft by processing command from telecommand and downlink data by telemetry. Fifth, flight software is responsible for operating the mission via the satellite hardware located in OBDH. The last one is the structure. In this mission is designed to endure the space environment for at least 8 years and withstand the thermal and vibration during launch period. In the mission timeline, ABOHISE-L5 is launched from Earth by SpaceX Falcon 9 in 2026 to GEO orbit. From GEO, the spacecraft accelerates the speed to Mars-like orbit at Lagrange 5 after 261 days from launch. In 2027 to 2033, ABOHISE-L5 turned the hyperspectral imaging for collecting mineral data on asteroid belts. After 8 years operation, in 2034, ABOHISE-L5 will retire as Lagrange 5.
Drawing insight from comparable missions, particularly from those embarking on journeys to orbit Mars, we estimate that the ABOHISE-L5 project would require a budget of approximately $2.82 billion. The challenge of this mission lies in the fact that no aerospace company has yet created a spacecraft to explore the asteroid belt by orbiting in a Mars-like orbit. This makes everything in our mission filled with challenges since there is not a wealth of data available. Moreover, our mission is expansive, covering over 140 million miles in exploration. Our project is currently in the concept design phase, but we are hopeful that our mission will be further developed and come to fruition in the future. Although our mission doesn't involve collecting valuable asteroid samples, what we gain from the endeavor is invaluable data, a blueprint for everything that will unfold in the future. This includes aiding in mitigating environmental impacts caused by industrial activities on Earth, contributing to sustainability efforts. The ABOHISE-L5 mission could be a pivotal contributor to sparkling interest in space mining among the next generation. It is our small yet significant step towards propelling the space industry forward. Thank you for your attention. ขอบคุณค่ะ